Welcome to Brain Vision.
So here in this problem, we are given this small rocket that is released from rest on a 10-degree inclined plane, as you can see here. Now this rocket has a total weight of 125 pound, and initial weight for the fuel in the rocket, this value we are given to be as 20 pound. This is the initial fuel, and the fuel is burned at a constant rate of 2 pound per second, and the relative exhaust velocity we are given to be as 400 feet per second. Now we have to calculate the maximum velocity reached by the small rocket. So this is what we are given in the question. Now to solve this problem, we'll be using Newton's second law of motion, that is sigma fx is equals to max, and this one is our x direction. This is the thrust force, this is the weight force, and the normal force offered by the plane. So this basically is a free body diagram of the rocket. Now we can use this law here, so we can write that t minus mg sine theta, or you could say w sine theta, is equals to max. And from here we have to calculate this thrust force first. So thrust force is basically m dash u, and m dash we have 2 pound per second. So let me convert the unit. 32.2 we are dividing with times 400. So will this get this value to be 24.8 pound. So the thrust force is 24.8 pound. Now this is the initial weight of the rocket, but since the fuel is burned at a constant rate of 2 pound per second, so the weight would be reducing as a function of time. So let us first calculate the weight. Let us calculate the mass basically of the rocket as a function of time. So it would be m naught minus m dash t, and m naught is the initial mass. So initial weight we are given to be as 125 pound. So mass would be 125 divided by 32.2 minus m dash is 2. So again divide with 32.2 to convert into mass flow rate times t. So we can further simplify this, and we can take 1 over 32 common, 32.2. So here we'll get 125 minus 2t. So this is m. Now next the propulsion time t. Now the weight of the fuel is 20 pound, and the rate at which the fuel is burned is 20 pounds per second. So propulsion time would be 20 divided by 2. So it would be 10 seconds. So in 10 seconds the fuel would be burned. Now let us put the values. So tension for this thrust force we have m dash u. So m dash u minus this weight is mg. This weight can also be written as mg, and m we have this much. So m naught minus m dash t times g sine theta is equals to m as it is, or we can write m as this way also. So m naught minus m dash t times dv over dt. Now this acceleration can also be written as basically the rate of change of velocity is acceleration. So this value we can write as dv over dt. So we have put all the values in this formula. Now let us further simplify this equation. So we can also write, we can take this term to the left side. So it would become m dash u divided by m naught minus m dash t, and minus this would cancel out, so it would be only g sine theta, and I'm taking dt to the left side, so dt, and is equals to, here we will get only dv. Now when we can integrate both the side. Now when the time is 0, the velocity is 0, and when the time becomes t, at any time t, the velocity would be v. So from here the expression for velocity comes out to be as u natural log m naught divided by m naught minus m dash t minus gt sine theta. Now we have all the values, we can plug it here. So this is u, we are given to be as 400 feet per second, so 400 natural log. Now m naught, so m naught is the initial mass. So initial weight we are given to be as 125 pound, so mass would be 125 divided by 32.2 divided by m naught minus m dash t. So m naught minus m dash t we can see from here, this is m naught minus m dash t, and this value is this much, 1 over 32 times 125 minus 2t. So we can plug it here, this is 1 over 32.2 times 125 minus 2t. Now t we have 10 that we have calculated earlier, this is 10, so times 2 times 10 would become 20. Now minus g is 32.2 times t is 10 and sine theta is 10 degree. So we can solve it by using our calculator, and we'll get our answer to be 13.83 feet per second. So this is the maximum velocity reached by the rocket. So I hope you have understood the problem. Thank you.